So we're going to create an example like number 9. It says calculate the following. So the mere fact the question says calculate the following. So multiplication is possible. To verify, you start to count 1, 2 across. 1, 2 across, 1, 2 down, multiplication is possible. 1, 2 across, 1, 2 down, multiplication is possible. 1, 2 across, 1, 2 down, multiplication is possible. Now, that's my first matrix. 1, 2, 3 across. So if I have 1, 2, 3 across, for multiplication to be possible, I must have put a matrix there, 1, 2, 3 down. Okay, I must put a matrix there, 1, 2, 3 down for multiplication to be possible. Here it is. 1, 2, 3 down. 1, 2, 3 across. 1, 2, 3 down. If I put, let's say I put a matrix like this. Let's say I put a 2 by 2. Or let's say I even put another 2 by 3. Let's say I put another matrix like itself. 2 rows and 3 columns. I put another matrix like it. Multiplication will not be possible because I have 1, 2, 3 across and only 1, 2 down. Okay, so multiplication will not be possible because I have 1, 2, 3 across. In the first matrix, I go in 3 across, 1, 2, 3 elements. And in the second matrix now to come down, I do in 1, 2. I'm missing a third one. Okay, so this will not apply for a question like number 9. So if I can put any 3 down. I put a 3 down there, 3 down there like this one. Let's put this one there, one like that. 1, 2, 3. Let's put a -1. So the 6. And let's say a 7. So yes, multiplication is possible because you have 1, 2, 3, 1, 2, 3. Okay. Now, what kind of matrix will I get? Remember we said the first matrix will control the number of rows. So I have 1, 2 rows, so my product will have 2 rows. And 1 column in the second matrix, my product will have 1 column. So I'm going to have a 2 by 1. My product is going to be a 2 by 1. 1, 2, 1. My product is going to be a 2 by 1. 2 rows and 1 column. 2 rows and 1 column. That's what my answer is going to be, my product. When you multiply, you get a product. So for you have to design a template for my product. I have to put a 2 by 1 matrix. So let's look for a 2 by 1. A 2 by 1, 2 rows and 1 column. 2 rows and 1 column. So 2 rows and 1 column. Bam. There it is. Now you might wonder now, how comes all of that giving you this? This is 2 rows and 1 column. Okay. So that's why multiplication matrices now, you have to be prepared for almost anything. Okay. So let's go over that again. Is multiplication possible? Yes, because 1, 2, 3 across, 1, 2, 3 down. Multiplication is possible. What will my answer be? What is the size of my product matrix? To know the size, you have to count the number of rows. 1 row, 2 rows. Not the elements, 1, 2. So my product must have 2 rows. 1, 2. Because one number making a row, you know. 1, 2. And how many columns will it have? One column. Because the second matrix has one column. So it's one column. So it's a 2 by 1. Now, remember when he said when you multiply matrices, you have to do some addition also, just to get one number. Okay? Here is an example. Just to get one number, you have to multiply and add. Okay? This is a 1 by 1. One row, one column, 1 by 1. Okay? This is missing the brackets. One row, one column, or 1 by 1. Because you must add just to get one number. Okay? So it's just a little. Okay? So these examples are very simple examples. Now, what are we going to multiply? We're going to multiply the numbers, the elements in the rows to the elements in the columns, just to get one number. So since we have 2 rows, we have to do that twice. You see, the whole multiplication and adding depends on how many rows you have in the first. I repeat, the number of times you have to do that multiplication and adding, it depends on the number of rows you have in the first column. So since we have 2 rows in the first column, we're going to do that multiplication and adding twice. Because we have 1 row, we do it once. And 1 column, we do it once. Now, since we have only 1 column, that's why you only do it twice, because it's only 1 column we have it. It's a 2 by 1. All right? Like 2 ones are 2. Okay. If it's a 3 by 3, probably 3 by 3, I have to do it 9 times. 3 times 3 is 9. It's a lot of work. So it's only twice you have to do it because we have 2 rows, but only 1 column. So those 2 rows have to organize, negotiate with that 1 column. If there was another column, it would be 2 times 2, 4. It would be 2 rows, 2 columns, 2, 1 row twice, another row twice, 2 twos are 4. Okay. So, based on what we did already, can somebody tell me, just to get that number there, that element inside the product here, what numbers I have to multiply and add? So as the student said, just like how it is in the example, 3 by negative 3, never 3 by 1. The first number in the row times the first number in the column, plus the second number in the row times the second number in the column, plus the third number in the row times the third number in the column, plus equal, just to get one number. So we're going to apply that here now. So the 2 now, I have to multiply 2, as he said, to negative 1. 2 to negative 1. So that's done. Plus, because we are not through, we haven't finished with the rule, neither the column. We have the 0 and the 5 and the 6 and the 7. So now it's the 0 turn. It's 0 times. So we're going across. As we're going across, so we're coming down. So it's 0 times 6 now. Plus the 5 times the 7. To get one number. Okay, when we equate that, we're going to get one number. Let me even put it there already. And so we're going to work this out just to get one number. And it's to get the second number now, that's the second row now we're using. So we're going down to the second row. So now is the one turn. So we have to go back and negotiate that very same column because it's only one column that there. So it's the 1 times 1 times -1 plus, we're going across and we're coming down 3 times x plus the 4 now times 7, just to get one number. So you can use your calculator. Remember this course, you can use calculator. I normally sometimes use Excel as my calculator. So equal, if you're using Excel as a calculator, just type equal in any cell, any box, equal. So it's 2 times -1 plus 0 times 6 plus 5 times 7. Enter. So that's 23. And to get the second number in that column, equal 1 times -1 plus 3 times 6 plus 4 times 7. 45. And here you have it. Multiplication of matrices. So apply this to these examples here.